On-screen big text. A black hole star. Voice. For 2 years, JWST has seen tiny red dots that are too bright, too early for the standard models of cosmology. What are they? Pause for the audience to read the question. Well, there are a lot of things that could explain these observations, and one team thinks their explanation is especially compelling. Black hole stars. That's right. New study posted to the preprint server, not a peer-reviewed journal, in September, suggests that some of these dots are actually shining because a black hole is eating away at the inside of a giant gas bubble and envelope surrounding it. The bubble would glow from all the energy released by the accretion, not because it's doing nuclear fusion like regular stars. Regular stars have fusion-powered winds that blow the bubbles. But for these hypothetical black hole stars, the wind has to come from something else. One idea is that the black hole itself is spinning rapidly, dragging the surrounding gas inwards. Another idea is that a disk of hot gas around the black hole is blasting out powerful jets that carve a hole in the bubble. Either way, if true, that would explain why some of these hypothetical black hole stars look so similar to young blue stars that are surrounded by gas. And it would explain why some of them appear to be much brighter than expected. It could even explain how supermassive black holes grew so quickly during the cosmic dawn. But before we go thinking that we've solved the mystery of the little red dots, let's pump the brakes. This is still just one proposed explanation for one possible class of objects. We're going to need more data, which luckily we're getting all the time, and we're going to need peer review. In other words, other experts are going to need to check the math on this paper. Speaking of other data, this week also brought another black hole spectrum from another bright red object dubbed QS01. This one doesn't have a catchy nickname. The paper calls it that. It's about 50 million suns in mass, and was previously known for having an extremely bright and compact core, possibly hinting that it too had a giant envelope of gas. The new spectrum confirms that it does. The gas is incredibly hot and whipping around at high speeds, and the black hole itself is spinning like a top at 70% of the maximum possible speed. But unlike the cliffs, this one looks pretty bare. There isn't any evidence for the heavy, cool gas that would normally form a thick shroud. It's about as naked a black hole as you could ask for. These two new results, combined with earlier work, hint that there may really be a whole population of black hole stars out there. If they're real, then that means black holes can grow supermassive in the early universe, without needing to wait until galaxies form. That is a big deal because these black hole stars might actually be the missing embryos. Of today's supermassive black holes, there are still plenty of open questions. How could they form in the first place? The leading ideas say either that they formed from primordial black holes that were produced by random density fluctuations in the early universe, or that they came from direct collapse. In other words, instead of forming from smaller stars that all individually collapse into a black hole, these would start out as huge clouds of gas that collapse directly into a black hole. Either way, it's clear that these hypothetical black hole stars could help solve the problem of how we got those big black holes so quickly. But again, we need more data and more scrutiny from the broader community. So while it's exciting, it's a bit premature to say that the mystery of the little red dots has been solved. Not every one of them is necessarily a black hole star, maybe genuinely weird galaxies. But either way, the debate will continue, and we'll be here to bring you the latest. Speaking of the latest, this week also brought news from LIGO. Their most detailed measurement yet of a black hole merger supports Stephen Hawking's famous area law that says the area of a black hole's event horizon increases when you add mass to it. It's a law that relates to how black holes store entropy, but I won't pretend I understand it. Anyway, it appears to be correct. And finally, we learned this week that the Mars rover Perseverance found minerals that are closely tied to biology on Earth. Don't get too excited. They could have an abiotic origin. We'll have to get those rock samples back to Earth to find out. So what do you think? Are those little red dots black hole stars or weird galaxies or something else entirely? Drop a comment below and subscribe so you don't miss next week's Space Flash. Thanks for watching.